So hey guys, welcome back to another lecture. So today we're going to discuss something known as integration. So in our previous lecture we have discussed a lot differentiation, etc. We have discussed a lot in differentiation, and we have discussed the rules, 12 different rules in the differentiation. So today we're going to discuss something known as integration. So what do you mean by integration? Just a area under the curve, right? So if you please review the introduction to the calculus and the integration and differentiation lecture, so that it will be easy to understand. So I just want you to go and watch it and then come again, so it will be easy to understand. So what is integration? Calculus of integrals. So what are the integrals? So you're gonna get it. So like it's just a calculations of integrals. So it denotes, so what it denotes the summation of the discrete data, right? So we're going to get all these in our further lectures, so don't worry. So just a finding of a antiderivatives of a function. So it is the process of finding the antiderivatives. So it is the inverse of the derivatives, means like we have a d by dx, right? So just the inverse of that, we have a integral f of x d of x, f of x into d of x, which is equal to g of x plus c. This is our formula over here. So this is the formula of the integration. So the c is here is a constant of the integration. Okay, so means like what it provides a way to compute the area under the curve at almost any function. Means like what do you mean by integration? It is the area under the curve, right? As we discussed in the previous lecture, to find the slope of the curve it is differentiation, the area of the under the curve is integration, right? So there are two kind of integrals. So what are they? There are definite integrals and indefinite integrals. So what are definite integrals? So an integral that contains the upper or the lower limits. So this is the integral, right? So this is an integral. This. So why we use this? So why we use the integral? So I just want to give assignment, right? So in a previous lecture I have given the differentiation assignment. So in integration I just want to give so why we use integrals, I just want to explore it on this is the assignment. Okay, so why we use integrals? Okay, so this is your assignment. So we have a two kind of integrals. One is definite integrals and another one is indefinite integrals. So what is definite integrals? Integral that contains upper and lower. So 0 to n, it containing upper and lower, and this is called as a definite. Means like it is having some kind of value in these integrals, so this is called as a definite integral function. And we have another one is indefinite integrals, means like they are defined without the upper and lower. So if you have a integral f of x d of x, there are no upper and lower, so this is called as indefinite integrals of this function. Okay, so I hope you get it. So what is definite and indefinite? Having numbers, this is called definite, and having no numbers, this is called as indefinite. So there are a lot of formulas out there, so I just want to please look it over it. So I think we have a 20 plus formulas in the integration. So to be honest, so I'm the bad person to give a lecture on this integration, because so I just got the 4 points in the mathematics B in my intermediate, in my plus 12. But I'll try my best. Okay, but I'll try my best to give intuition about what is integration. Okay, so we don't need that how we calculate this. We have computer and we have a beautiful libraries out there. So why we need to waste our time, right? So we have a beautiful libraries out there, and we have a beautiful computations, right? So if you typed it, then we're gonna get our output, right? So it's a good to know like how they're gonna work, etc. So I just want to explore all the formulas out there. So please look into it and take use of the chat GPT and Google. So we have a great resources out there. So Google and the chat GPT, this is the best teacher you will ever find in our life. So I just want to give a diagram over here. So this is the area under curve, right? At a particular point P1, P2, P3, how we find the points? So if we have an equation, right, we have an equation over here. So we have a y-intercept, x squared plus c. So how we find these? We just simply we just simply take the c values here, just simply plug in the some sort of values over here, and we will get our output, right? We will get our output, and we just simply plot these in the graph, and we will get our beautiful curves over here, right? So at point 4, the integration of that is the area under this curve, right? At point 3 means like it calculates the area under the curve at a certain portion, right? You just submit all the portion. So this is the integration. I hope you're getting a basic understanding like what is the integration. It's just a area under the curve, right? So it is the area, this is the area under the curve at a point P4. We have points out here, that's it, okay? So there are different types of rules in the integration. In our differentiation also we have 12 kind of rules, right? So there are many rules, but I just given a few, so I just want you to explore it on own. So we have a addition rule. So we have a, if we have a f of x and g of x are differentiable functions, then we have a integral f of x plus g of x, which is equal to the integral f of x dx, and we have integral g of x dx. Okay, I hope you're getting it. So we just simply dividing this is the addition rule, okay? So for example, in our practical example, like we have a integral f of x plus f2x all the way to the f n x, okay? This is equal to the f of x dx plus f2x dx all the way to the f n x dx. I hope you're getting it. So we just simply take it out. And finding derivative, and this we find in that, and we find in the derivative integral. So sorry. We find in the integral of first function, and we adding that to the second, and we adding to the third. So I hope you're getting this. Okay. So after that we have a subtraction similar to the addition rule, but we had subtraction over here. So same as the function, but we had subtraction over here. So we have these two functions, and we just simply subtract these functions. So we have a fx, f1x, f2x, fnx all the way to the fnx, and we just simply find the f1 and then f2 and then fn. Okay, we just simply subtract this. We have addition over here, we have a subtraction over here, just similar to that, and we have a multiple over here, multiple rule. We just simply multiply this. So with the help of the constant, here the k is constant, we just simply multiply with the constant. It's just similar to the scalar vector product, or we have a constant multiple rule in our differentiation, right? So we multiply with the constant. So whatever it may be, the constant may be 5, we get the 6 or 7. So just a constant, and we just simply multiplied with the equation, right? So we just find the integral of the constant into f of x into d of x. Then that is equal to the, we just simply bring in the constant outside of this integral, and then f of x d of x, we just simply find that. So I just want to give a practical example. We have a phi of f of x d of x. We just simply take out the phi outside, and we find the integral of that function. So don't worry if you don't understand these integrals and these things. So many people will have a lot of fear, including me, in these integrals, okay? So don't worry about that. So I'm confident, right? So don't worry about it, because we have as I said, like we have a beautiful libraries over there to make our job easy, okay? So don't worry if you didn't get, we're gonna do in a computer, so it will be easy, okay? So it will be easy. So I just want to give a outro for this integration. The total integration revolves around the word isolate. It's not I love, it's isolate. So what is isolate? So what I means inverse, and L means logarithms, and A is algebraic, and T is trigonometric, and exponential C means, right? So the integration revolves these 5 letters. The integration revolves on these 5 letters, okay? Inverse, logarithms, algebraic, trigonometric, and exponentials. The whole integration revolves around this word, okay? So I think I covered a basic introduction about the integration, and I hope you enjoy this lecture. So this is the last lecture on this calculus. So thank you for making this much for like completing 3 modules, which is linear algebra, and matrices, and this calculus. And in our next lecture, in our next module, we're gonna discuss the probability and statistics. These are the main in our machine learning and the data science. These are the main in our machine learning and data science. So I hope you love these lectures. I hope you love these lectures. So if yes, and please like this, and please like this lecture, and I just want to share with your friends if you like this lecture only. If you don't like, then please don't share it, and please don't watch. I'm working so hard for the videos, like making the notes. It took me 2 days to research and write down all the notes for you guys, and I just want to giving these notes if you want. So if you want the free notes, so I wanted you to comment below, like, I want the free notes. So I just want you to comment like I want notes, like I want free notes, or whatever it may be. Whatever it may be, just comment down below. I'm gonna reply your comment, and I will send this PDF, which is 41 pages, a beautiful notes over here. So and next we're gonna discuss the probability and statistics. So I just want you to review the lecture. So I just wanted to review what I have said till this for like, we have discussed a lot since from the beginning, from the scratch, from the calculus, right? From the scratch, like what is calculus and how we use it, and we have differentiation, integration, we have a function, and we have a composite functions, parabola, a lot more, trigonometry, Sakatova, and we have a unit circle, and we have discussed the beautiful unit circle, and we have a limits over there, and we have a discontinuity, continuity over here, and we have a 3 kind of functions over there, and we have a squeeze theorem, which is also a sandwich theorem, and we have a beautiful notes over here, which is differentiation, when we have discussed the 12 differentiation rules over here, and we have a integration over here, and this is the end of this module. So see you in our next module, which is probability and statistics. So I hope you enjoyed this lecture. So until then, bye bye, see you in the next lecture.